So using Pascal's triangle, first of all, if you were expanding this completely, because the exponent is 3, it tells you have 4 terms. And from Pascal's triangle, if you go to the row that has 4 terms, that tells you what the coefficients are going to be. And so you can start by writing those in green: 1, 3, 3, 1. Then we've noticed that our first term in the binomial, which I've underlined in blue, it starts with 3 of them because your exponent is 3. Then you have 2 of them, then you have 1, and your last term doesn't have any of that first term. This is the one not off to the side, but the main one. And then your second term, which is -1, you don't have any to begin with. Then you have 1 here, then 2, and then 3. And if you simplify it, this is the answer that you get. Now, if we had a bigger thing to figure out, like if you had 3x minus 2y to the 17, how many terms would there be? 18 terms. So if you had to expand this completely, it would take a long time, because first of all, you'd have to go Pascal's triangle, keep going, and the numbers get big. And then you would have to keep figuring things out. So what we're going to look at is how can we look and examine what happens here to figure out a pattern. Because usually with these bigger ones, they just ask you something small, like, can you find term 5? I'm not worried about finding them all, but can you find term 5? And what does it look like? So when we look at the pattern, well, the green numbers are from Pascal's triangle, but the green numbers also are combinations. This 1 is really 3 choose 0, and this is 3 choose 1, and this is 3 choose 2, and this is 3 choose 3. So if we had a power of 17 and we were trying to find what term 5 is, does it make sense that I would have 17 choose something? What would that something be? 4. Because we notice that in the first term you choose 0, in the second term you choose 1, in the third term you choose 2, that whichever term you're choosing, it's 1 less to figure out that green number as a coefficient. Then your blue number, which in this case is 3x, what's the power going to be for that one if you're finding the 5th term? It's going, not 12. Check it out. With this one, where it's 3 choose 0, can you see that this 3 is 3 minus 0? And this one where it's 2, it's 3 minus 1. And this one, 3 minus 2. So for ours, for the 5th term, it's going to be 17 minus 4. It's going to be to the power of 13. Because if you think the first one's going to be to the power of 17, then 16, then 15, then 14, then 13. So the 5th one would have to be to the power of 13. And then your second term, which we did here in red, so I'll write it here, negative 2y in red, what power is it going to be? Right? Check it out. The first one has none. The second one has 1. The third one has 2. The fourth one has 3. It'll just be 4. Because the first one will have 0, the second one would have 1, third one 2, fourth one 3, fifth one would have 4. So we can use this pattern to figure out a specific term, and what we get from this idea is the following pattern. So they've got it at the bottom here, the general term. This is how the textbook writes it. In the black box here is how it's written on your formula sheet. So I'm going to rewrite the question that we just came up with. I'll go 3x minus 2y to the 17. Scroll this up so you can write that down. So if you had for 3x minus 2y to the 17, and you wanted to find term 5, one thing that this formula tells you is that whichever term you're finding, term 5, what's the value of k then? It's always going to be 1 less. Because if I want to find term 5, and the formula works for term k plus 1, then k would have to be 4 in order for me to find term 5. Your n, that always comes from your exponents. So in our case, it would be 17 choose, whoops, k would be 1 less, 4. Our first term, a, is 3x to the power of 17 minus 4. And our second term, which is negative 2y, to the power of 4. Then when you go to simplify this expression, what you're going to do is it's sort of broken up into 3 parts. There's your combination, which I've underlined in green, your first term in red, and this one in black. You're going to simplify each of those separately. And we can get some very big numbers, and we are going to get some very big numbers in this one. So if I go to my calculator and I go 17, choose 4, that's 2,380. Here I'm going to get 3 to the power of 13. Yep, that's not small at all. 1, 5, 9, 4, 3, 2, 3. And I will have x to the power of 13 as well. And here I'm going to have a negative 2 to the power of 4. Is that going to be a positive answer or negative? It's going to be positive. Y to the 4. So first you're going to simplify each of those things, 3 things separately. And now when you have to multiply all of these together, you're going to multiply your numbers together. So 16 times that big number times 2,380. Nice. It has to go to scientific notation because it's so big. 6.07 times 10 to the 10, x to the 13, y to the 4. This would not have been fun with Pascal's triangle and those big of a number, those numbers that big. But this is what we're going to do when it's bigger. They're going to ask for a specific term. So if we go to example 3 now, the numbers aren't quite as big, but it says find the 9th term in the expansion here. So on your formula sheet, you have this formula. You want to find term 9. What do I put in for n? N is always your exponent, so that'll be 10. What am I going to put in for k? 8, because it's k plus 1, and since I'm finding 9, k would have to be 8. A, that's just your first term, which is x, 10 minus 8. And b, anytime there's a negative, that goes with the b value to the 8. So again, we calculate each of these separately first, put them in brackets, so term 9 equals 10 choose 8, 45, x squared, negative 2 to the power 8 would be a positive number, 256. And term 9, 11,520 x squared. Yes? That doesn't exist? No, you'll always get an answer that is valid. And they're always the same. So this is about, well, I'm going to give you about 10 minutes to work on questions 5 and 11, and then I'm going to show you what do the most difficult binomial theorem questions look like. Morning.